We're given vectors u, v, and w. Notice how the third component of vector w is h. And we're asked for what value of h is the vector w in the plane spanned by vector u and vector v. This occurs when vector w is a linear combination of vectors u and v, which means there must exist two scalars, which we will call c sub 1 and c sub 2, such that c sub 1 times vector u plus c sub 2 times vector v must equal vector w. So if we fill in the vectors, we have the vector equation c sub 1 times the vector 1, 4, negative 2 plus c sub 2 times vector negative 2, negative 3, 7, and this must equal vector w, which is the vector 4, 1, h. And now let's perform the scalar multiplication on the left and then add the two column matrices. This will result in one 3 by 1 matrix, or one column matrix, where the first entry is c sub 1 times 1 plus c sub 2 times negative 2, or c sub 1 minus 2 c sub 2. The second entry is c sub 1 times 4 plus c sub 2 times negative 3, or 4 c sub 1 minus 3 c sub 2. And the third entry is c sub 1 times negative 2 plus c sub 2 times 7, or negative 2 c sub 1 plus 7 c sub 2. This is equal to the vector 4, 1, h. And now let's write this matrix equation as a system of equations, where the first equation is c sub 1 minus 2 c sub 2 equals 4. The second equation is 4c sub 1 minus 3c sub 2 equals 1. And the third equation is negative 2c sub 1 plus 7c sub 2 equals h. Notice here we have a system of three equations with two unknowns. But because we only have two unknowns, what we can do is solve the system using just the first two equations to find c sub 1 and c sub 2, and then we can use those values to find h in the third equation. So let's write the augmented matrix for the first two equations, where the first row is 1, negative 2, 4, and the second row is 4, negative 3, 1. And now let's write the augmented matrix in reduced row echelon form. Let's get a 0 in row 2, column 1, by replacing row 2 with negative 4 times row 1 plus row 2. And since the least common multiple of 2 and 3 is 6, let's replace row 1 with negative 2 times row 2 plus 3 times row 1. Replacing row 1 with negative 2 times row 2 plus 3 times row 1, we have negative 2 times 4, which is negative 8, plus 3 times 1, which is 3. Negative 8 plus 3 is negative 5. And then we have negative 2 times negative 3, which is positive 6, plus 3 times negative 2, which is negative 6, giving a sum of 0. And then negative 2 times 1 is negative 2, plus 3 times 4, which gives us negative 2 plus 12, or positive 10. Now we replace row 2 with negative 4 times row 1 plus row 2. Negative 4 times 1 plus 4 is 0. And then we have negative 4 times negative 2, which is positive 8, plus negative 3, which is 5. And then finally we have negative 4 times 4, which is negative 16, plus 1, which is negative 15. And now to get leading entries of positive 1, let's replace row 1 with negative 1/5 times row 1. And let's replace row 2 with 1/5 times row 2. Which gives us 1, 0, negative 2 in the first row. And the second row is 0, 1, negative 3. The first row indicates that c sub 1 is equal to negative 2. And the second row indicates that c sub 2 is equal to negative 3. Now that we know the values of c sub 1 and c sub 2 that satisfy the first two equations, we can now determine the value of h by performing substitution for these values into the third equation. Performing substitution, we have negative 2 times c sub 1, which is negative 2, plus 7 times c sub 2, where c sub 2 is negative 3, and this is equal to h. Simplifying on the left, negative 2 times negative 2 is positive 4. 7 times negative 3 is negative 21, giving us 4 minus 21 equals h. h is equal to negative 17, which is what we were trying to find. H must be equal to negative 17, which is the third component of vector w, so that vector w is in the plane spanned by vectors u and v, which means vector w is a linear combination of vectors u and v when h is equal to negative 17. I hope you found this helpful.